everybody, today we're going to be looking at 6.4. There's going to be two parts to this. There's going to be the part for the regulars that both the regulars and the honors need to watch, and then there's going to be an honors part at the end. I'll let you know when you can stop watching, but for now, go ahead and keep watching. So today the idea is, last time we looked at multiplication division. Today we're going to look at addition and subtraction of rationals. And then for the honors, we're going to kind of throw all that together. So let's get into it. Remember, when I'm adding together fractions or really division, rationals, I need to have the bases be the same. It didn't matter with multiplication and division. It does matter with with addition and subtraction on rationals. So I need those bases, those denominators to be the same. So what I'm going to do here on this first, or let's just do number two because it's a little easier to write, is I want to find what we call the least common denominator. So for that, what I want to do is I want to actually break this up. And again, this is kind of like factoring, right? Taking out parts, plus 8 over 5. Okay, well, what I can see here is I have a 5 here, I have a 5 here, I have a 2 here, but I'm missing a 2 here. So what I want to do is I want to give this one a 2. But of course, I can't just give the denominator a 2 because that would change my question. It's not the same question anymore. But remember, we always have that trick of multiplying by 1 to not change anything. And we're multiplying by a very specific one, in this case, 2 over 2. So what this is going to turn into, and we can put it back together at this point, is 7 over 10 plus, and again, multiplication, just looking at this last part here, 16 over 10. Now my denominators are the same. Once they're the same, I can combine them. Remember, when you add fractions, denominators stay the same, and then numerators get added or subtracted. And honestly, if you can do that, you're gonna be fine today. If you are struggling with that, then make sure you're coming again for that RTI time for extra help. So that being said, and again, this is going to be a 2-day lesson. I'll kind of give you the idea of where I want to break that up. But if you're virtual, I would go ahead and just watch the whole thing and then spend 2 days working on it. These do take a little bit longer because you have to factor, combine them, or distribute, and then factor again. There's a lot of factoring going on in this section. So again, if you're struggling with factoring, RTI time, office hours if you're virtual, make sure you're coming. Don't wait till the last day, please. So what we need to do is this idea of we need to get our denominators to be the same and then add our numerators. That's exactly what is happening in these, or subtract as the case may be. And really that's what it comes down to. Add the numerators, simplify. Now we do have that simplify step. So that being said, let's look at a couple of these. These are all already where the denominators are the same, which is nice. Just as kind of a quick, hey, remember this is what we do. So remember the numerator, or sorry, the denominators stay the same. We're not going to touch those. And the numerators get whatever's happening, addition or subtraction. In this case, subtraction. So we're going to have 3. Now I do want to check for simplification. I can see here that I have some simplifying going on. Do not simplify until the end. Okay, so in the other one, it was kind of okay to simplify early. On addition and subtraction, do not simplify till the end. So here, because if you're simplifying, you're basically undoing all the work you did. So for here, you're going to have this gets simplified by 3, so I'm going to be left with 1 over 4x. Okay, here, again, denominators just stay the same, assuming they're already the same. 2 plus 1 is 3. I can have some simplifying going on here by 3, so 1 over x squared. Okay, remember that 1 was there, but we don't really need that one. We do need the numerator. Okay, same thing here. We've got, now let's be careful here, because we're going to have 4x minus x over x minus 2. Okay, 4x minus x, this is like a 1, right? So subtracting is going to be 3x over x minus 2. Can't really do anything with that. Okay, up here, 2x squared plus 2, x squared plus 1. Okay, I could take a 2 out of this top. Let's do that. And then x squared plus 1, cancel, and I'm left with 2. Okay, so that's kind of the goal here. And if our denominators are nice, those are they're already the same. That's not too bad. It's when they're not the same that we have issues, and we need to get them to be the same. So first step on all of these, factor everything. Just go ahead and do it. And actually, really, you're looking at the denominator because that's what's going to be your biggest issue is the denominator. So factor the denominators. So step one, factor denominators. You can hold off on the numerators for now. Dominators. Okay. You can hold off on the numerators for now if they are factorable. These ones aren't, but if they are, you can hold off on for now. So I've got, and I want to think about this 9x squared for a second, because really, let's do the second one first. It's gonna be a little easier to see. So I can factor 3x out of this, and I'm left with x plus 1. Okay, if I think about 9x squared for a second, that's really 3x times 3x. Okay, and I'm doing that for a reason. I'll show you why in a second. So what I see is on my first one, I have a 3x, and I really have a second 3x. In my second one, I only have one 3x, and I only have one x plus 1. Okay, whereas my first one, I didn't. So the goal at this step is we're going to multiply by all the missing parts. And this is the hardest step, to be honest, because it's the step that freaks people out. All we're doing here is multiplying by 1. That's it. We're multiplying by very specific ones, but we're multiplying by 1. So what I want to figure out is on each part, what am I missing? And we're going to multiply by that. So looking here, I am missing in my denominator an x plus 1. Don't worry about the numerators. The denominators we need to be the same. So I am missing an x plus 1. Oops, sorry. So I want to multiply by x plus 1 over x plus 1. For my second term, I have one 3x, but I need two of them, okay? And that's the only thing that's missing from that one. So I want to multiply the second term by 3x over 3x. Okay, now the way I recommend you do these is multiply each part. Just look at one part. So I'm going to look at just this first part for right now. Okay, so I've got 7 times x plus 1 over 3x, 3x, x plus 1. Okay, looking at my second term, and there's going to be an addition between these. I've got x times 3x, which is really just 3x squared, over 3x, 3x, and x plus 1. Okay, now I know what you're thinking. You're thinking, hey, wait, can I cancel something out here? You don't want to, though. Canceling out here is just going to undo what you did, and you never want to do that. Okay, so don't cancel out until a little bit later. Okay, so step 3, we want to combine. So I'm going to take these and combine them. Okay, now really remember this is 7x plus 7. Okay, so combining my numerators, I'm going to have 3x squared. Remember, addition is commutative, so I can move it around. Just keep everything together. Over 3x, 3x, and x plus 1. Okay, now at this step, we want to check and see if we can factor the numerator. If we can factor the numerator, then we want to check for canceling. If we can't, then we're done. So looking at my numerator, I'm going to have 21, 3, and there's nothing, or sorry, 7, and there's nothing that can get me from 21 to 7, because the only options for 21, positive 21, specifically, um, are 1, 21, 3, and 7, and that's it. So I can't get to 7, so I couldn't factor that numerator. So this is going to be my answer. We'll look at one in a little bit where stuff does end up canceling. Okay, so factor those denominators, multiply by the missing parts, combine, and then check and see if you can factor and cancel. Okay, subtraction is no different. The only difference is that you are subtracting, but the process is exactly the same. So factor the denominators if possible. So x plus 2 over 2, x minus 1, minus, oops, let's actually go ahead and factor that. So let's say x minus 3, x minus 1. Okay, now, trick you can use here. And you want to use it at this step or the first step, either works. If you're subtracting, you can just distribute that negative. So I can take this negative and distribute it to all the parts. And when I do that, it just changes all the signs. Okay, so let's rewrite this. X plus 2 over 2, x minus 1, plus 2x plus 1 over x minus 3. And now it's not subtraction, it's just addition. Okay, so a little pro tip for you there. At this point, I want to see what I'm missing, what I need to multiply by. So I've got a 2 here, I've got an x minus 1 here, I've got an x minus 3 and x minus 1. So my first term is missing this x minus 3. My second term is missing this 2. So the first term is going to get multiplied by x minus 3. Let's put some parentheses around these. Over x minus 3. And my second term is going to get multiplied by 2 over 2. X minus, oops, 3, x minus 1. Okay, I'm multiplying all that out. Now I do want to multiply this top part. I do want to distribute. So that's going to distribute into x squared minus x, minus 6 over. Okay, you do not need to do that with the denominators. You only need to do it with the numerators. Leave the denominators for now. There's no point in doing it. Plus, distributing this 2, I'm going to get 4x plus 2 over 2, x minus 1, x minus 3. Okay, remember, as long as you're keeping things together, multiplication is commutative, you can move it around. At this step, we want to add these numerators. So x squared minus x plus 4x is going to be plus 3x, minus 6 plus 2 is going to be minus 4 over 2 x minus 1, x minus 3. Remember, the denominators don't change. Okay, now this is one where you can factor the numerator. So if I factor that numerator, I'm going to get x minus 1, x plus 4, which we can see is going to cancel with something. So my x minus 1's cancel, and I'm left with x plus 4 over 2x plus 3, which again, may be your answer, and yay. If not, then you do need to distribute that too. No problem, though. It's going to be, I'm going to put this up here. So we have x plus 4. Sorry, my camera's in the way. 2x plus 6. Okay, both of these are answers. Again, just depending on what you're doing. If you're working on ACT, you may see one over the other. Okay, so that extra step here that I was talking about from the last one is you do want to factor the numerator if possible. Couldn't do it on the last one. We can do it on this one. And then cancel anything out that cancels. Okay, and that's the bulk of the lesson. This would be kind of a good stopping point if you want to split it into 2 days, but that is the bulk of the lesson. Okay, here's just some more practice. I don't know why this is off. Let me fix that real quick. There we go. And really, you're just doing the same thing. Okay. You're going to take these. I'm going to do that last one there because it's the most complicated one. So I've got X. Actually, let me just move some of this around. Just get rid of that. There we go. Let's get rid of this guy. If it'll let me get rid of one. Yep. Okay, let's just use this one for right now. Okay, so factor the denominators. So denominator here is going to factor in x minus 4, x plus 3. This, I can take a GCF out, x minus 4. Okay, I can see they have an x minus 4 in common. That's nice. They don't always have to have something in common, but they can. So my first one's missing this 12. My second one's missing this x plus 3. So I'm going to multiply that first one by the 12 over 12. And the second one by the x plus 3. First one is going to turn into 12x. We do want to multiply the tops or the numerators. Don't worry about the denominators right now. If we need to, we'll combine them later. Numerators, you do need to combine though before you add or subtract. Multiplying, distributing. So 5x plus 15, just again, distributing. Don't touch the denominators, leave them like they are. Okay, combine my numerators here. So I'm going to have 27x plus 15 over 12, x minus 4, x plus 3. Okay, I can take a 3 out of this numerator here, so let's do that. Yeah, okay. Take a 3 out of that numerator, so I'm going to have 3, and then 9x plus 5 over 12, x minus 4, x plus 3. I can simplify this down by 3, so I'm going to end up with 9x plus 5 over 4, x minus 4, x plus 3. Okay, and there's my answer. Okay. Now that is it for the regulars. If you are in one of my regular classes or my virtual, remember virtual is regular, then you're good to stop the video at this point. Please make sure you are coming for RTI time though if you're needing it for that extra help. As far as the honors, please keep watching. I need to show you kind of the complex solutions here. Now, when I talk about complex here, I'm not talking about imaginary solutions. Again, this is one of those areas in math where we use a lot of they're the same word for a lot of different things. Um, but what a complex looks like is this. Now, I know it looks gross, but it's actually not too bad. Watch this. So what I want to do is I want to find the part that has addition. Okay, now that could be in the denominator, it could be in the numerator, or it could be in both. Doesn't matter. But any addition or subtraction you want to do first. Okay, I know it's kind of opposite of what we want to think of outright because PEMDAS tells us, hey, additions last. But remember, if I'm really following PEMDAS, division happens first, right? But for me to be able to do, because really there's like big parentheses around this, for me to be able to do the division between here and here, I need to deal with this first. So because of that, I do need to combine any addition and subtraction first. Again, it's a little counterintuitive, but it's not too bad. So let's look at just the denominator here. Let's not even worry about the numerator right now. Let's come back to that. Let's look at just the denominator. So the denominator is 1 over x plus 4. And honestly, this is probably the best way to do these, is look at it piece by piece. Do what we just did. Okay, so this is missing an x. This is missing an x plus 4. X over x. Second term is missing an x plus 4. Okay. Combining this, I'm going to get x. Now, again, I would leave it not the denominators, just leave them like they are for right now. Numerators, you do want to combine before you start adding. So 2x, that's a really gross 4, sorry about that, over 8. x plus 4. Okay, combining those numerators, I'm going to get 3x plus 8 over x times x plus 4. Okay, so now this is my new denominator for that big one. So I want to put it back. Okay, and I want to say 5. Remember, division is really just, or fractions are really just division. So let me rewrite this a little bit. Or let me put it back and then I'm going to rewrite it. So I'm going to say 5, sorry, excuse me, x plus 4, big division, 3x plus 8, x plus 4. Now again, remember we are just replacing this back here because this is equivalent. Okay, but remember, really this is division. Let me rewrite this so it looks a little nicer for us. And just say, let's use that old school division symbol here and say 3x plus 8, sorry, over x plus 4. Okay, now remember, keep flip change. So 5 x plus 4 times x plus 4 over 3x plus 8. Okay, now multiplication, we can cancel these guys. We're left with 5x over 3x plus 8. And then there's my solution. Okay, so there's a little bit more time consuming, and really it's just doing what we did last time and the time before that. So like it's taking that multiplication and division part. Really, the division is what we're looking at here with the addition and subtraction. So do that addition and subtraction first, like we just did. Replace it, and then do the multiplication or division. And really, that's it. Like if you can do each of those individual things, it's not more complicated. It's just do the addition subtraction like we did today first, and then the multiplication, really division, like we did before. If you have any questions, feel free to come during RTI Fridays. More than willing to help you on that. But really, again, don't overthink these too much. Really, it's do the addition and subtraction, then the division. I will see you guys next time.